Assalamualaikum and good morning everyone. My name is Abdul Aziz bin Azmi from Mat 3. Today I would like to present about the integration of computational thinking in Year 2 Mathematics. My topic is a non-routine approach to the addition of two numbers. Normally, when Year 2 pupils learn mathematics, they are usually taught simple addition questions. They are given two numbers and they only need to add them together to find the answer. However, in this presentation, I want to show that mathematics can be taught in a more interesting way by integrating computational thinking. Computational thinking helps pupils solve problems systematically. Instead of memorizing answers, pupils learn how to think, analyze, and solve problems step by step. This is important because pupils need problem-solving skill not only in mathematics but also in their daily lives. Through this presentation, I will explain how computational thinking can be applied in a simple Year 2 addition lesson. We move to the slide 2. This lesson is designed for Year 2 pupils. The main topic is addition of two numbers. At this age, pupils are still learning basic mathematics skills, so the teachers usually use simple and familiar situations. For example, Siti has 8 pencils. Her mother gives her 5 more pencils. How many pencils does Siti have now? For this question, pupils only need to calculate 8 plus 5, which equal to 30. This is called a routine question because pupils know what operation to use immediately. However, if pupils only answer routine questions, they may depend too much on memorization. They may know the answer, but they may not understand how to think critically when they face a more challenging question. That is why teachers should expose pupils to non-routine problems as well. This lesson also includes 3 computational thinking skills, which are decomposition, pattern recognition, and algorithmic thinking. These skills help pupils become better thinkers and problem solvers. We move to the slide 3. In this slide, we can see the difference between computational thinking and heuristics. Computational thinking is a systematic way of solving problems. It teaches pupils how to think carefully and logically. There are 3 important computational thinking skills in this lesson. The first is decomposition. Decomposition means breaking a problem into a smaller part so that it becomes easier to solve. The second is pattern recognition. Pattern recognition means identifying similarities, repeated numbers, or repeated sequence. The third is algorithmic thinking. Algorithmic thinking means solving a problem by following clear and organized steps. Besides computational thinking, pupils can also use heuristics. Heuristics are practical tools or strategies that help pupils solve problems more easily. For example, pupils can draw pictures, use objects, count with fingers, or use a number line. These heuristics are very important for young pupils because they help pupils see the problem visually and understand it more clearly. We move to the slide 4, the non-routine challenge. Now let us look at the non-routine problem in this lesson. Ali has 6 candles. Ali has 6 candies. His sister gave him some more candies. Now Ali has 10 candies. How many candies did his sister give him? This question is more challenging because the missing number is not given directly. Pupils cannot immediately see the answer. Instead, they need to think carefully. They need to ask themselves, if Ali already has 6 candies, how many more candies are needed to make 10? This type of question is called a non-routine problem because pupils need to think beyond simple memorization. It encourages pupils to analyze the situation and find the missing number. The answer is 4 because 6 plus 4 is equals to 10. Although the answer is simple, the process to finding the answer is more important because it develops pupils' thinking skills. Next, we move to the slide 5, characteristics of non-routine problem. There are several characteristics of non-routine problems. First, there is an information gap. This means pupils are not given the complete answers directly. They need to identify the missing number by themselves. Second, there is cognitive load. Pupils need to think more deeply and use different strategies to solve the problem. Third, there is tool utilization. Pupils can use heuristics such as pictures, fingers, number blocks, or number line. These tools help pupils understand the problem more clearly. Finally, there is autonomy. Pupils need to solve the problem independently. This is important because it builds pupils' confidence and encourages them to become independent learners. In this example, the final goal is to find that 6 plus 4 is equal to 10. We move to the slide 6. There is decomposition. The first computational thinking skill is decomposition. Decomposition means breaking a problem into smaller and simpler parts. For this question, pupils first identify the starting number, which is 6. Next, they identify the final total, which is 10. After that, they think about how many more candies are needed to go from 6 to 10. Pupils can count step by step, 7, 8, 9, and 10. When they count these numbers, they can see that 4 more candies are needed. This skill is very useful because pupils do not feel overwhelmed by the problem. Instead of looking at the whole question at once, they solve it one step at a time. This makes the problem easier and less stressful for young learners. We move to the slide 7. Pattern recognition. Pattern recognition means looking for repeated patterns or relationship between numbers. For example, 6 plus 1 equal to 7. 6 plus 2 equal to 8. 6 plus 3 equal to 9. 6 plus 4 equal to 10. From this pattern, pupils can see that the total increases by 1 each time. This helps them understand that the missing number is 4. Pattern recognition is important because it helps pupils see connection between numbers. It also improves their number sense and help them understand how addition works. When pupils become familiar with number patterns, they can solve future questions more quickly and confidently. We move to the slide 8, algorithmic thinking. The third computational thinking is algorithmic thinking. Algorithmic thinking means solving a problem using clear steps. For this question, pupils can follow 4 simple steps. Step 1, look at the starting number. Step 2, look at the final total. Step 3, count how many more are needed. Step 4, write the answer. For this example, the starting number is 6 and the final total is 10. After counting, pupils know that 4 more candies are needed. Therefore, the answer is 4. This skill is important because pupils can use the same steps for many other problems. It teaches pupils to be organized and systematic when solving questions. We move to the slide 9, lesson flow. These slides explain how the lesson can be carried out in the classroom. The lesson begins with a set induction for 5 minutes. The teacher shows a picture of candies and asks pupils a question such as, Ali has 6 candies. How many more candies are needed to make 10? This question helps attract pupils' attention and prepares them for the lesson. Next is step 1, which takes around 20 minutes. During this stage, pupils read the question, identify the important numbers, and count how many more are needed. After that is step 2, which takes around 25 minutes. Pupils work in small groups using number blocks or candy pictures. Finally, the lesson ends with a closure session for 10 minutes. The teacher summarizes the lesson and asks pupils what they have learned. We move to the slide 10, collaborative problem solving. This lesson also includes 21 sensory learning strategies. One example is think, pair, share. First, pupils think about the answer individually. Second, they discuss their ideas with a partner. Third, they share their answer with the class. This activity is very useful because it encourages communication and teamwork. Besides that, pupils can also use physical objects such as number blocks or toy candies. Using physical objects makes learning more active and enjoyable. Pupils can touch, count, and move the objects while solving the problem. This makes the lesson more interesting and easier to understand. So we move to the slide 11, impact of computational thinking. There are many benefits of integrating computational thinking in mathematics. First, pupils learn to think systematically. Second, pupils develop stronger problem-solving skills. Third, pupils become more confident in answering difficult questions. Besides that, mathematics become more interesting and enjoyable. Pupils also learn how to work effectively with their friends. These benefits are very important because they help pupils not only in mathematics but also in other subjects and daily life situations. Overall, computational thinking helps year 2 pupils solve addition problems more easily and enjoyable. In conclusion, computational thinking is very important in helping year 2 pupils solve non-routine addition problems. Through decomposition, pattern recognition, and algorithmic thinking, pupils can solve problems more effectively. This approach also makes mathematics more interesting and meaningful for pupils. Instead of memorizing answers, pupils learn how to think critically and solve problems step by step. As a result, pupils become more confident, independent, and creative learners. Thank you for listening my presentation.